Come forward. Silence. Okay, the next is, I said silence. The next I'm going to discuss about the shift operator. You sit here and you can't come here. Come this way. Come, last benches, come this way. You can sit here, not there. Here, come. Okay, now silence. Now I'm going to discuss about the shift operator. Okay, that is arithmetic shift as well as normal is silence. Here I'm going to discuss about the shift operator. In the shift operator, we have normal shift operator as well as arithmetic shift operator here. Okay, and here whatever you see, this is, see here you can check the program by writing you can verify the program using Verilog language using edaplayground.com. Silence. This is the online tool, online compiler. You can write the Verilog program and you can verify the program and you can check here. Okay, in order to understand and analyze the concept called logical operator, arithmetic operator, shift operators, relational operators, reduction operators, whatever you want, you can check and verify using this is the online link. Okay, that's it. EDA playground. See here, not seeing this one. edaplayground.com. Huh? Okay, and now silence. Here in this, are you able to see now? You make it light. So bright, make it dim. Not bright, reduce bright color. Reduce bright. Zoom little bit and reduce the brightness. Reduce the brightness. Silence. Press the pause button. Don't laugh. We are nothing. Come and go. Then it comes already. Come to do it, then you know what is the difficulty. Turn on the power. Press pause button. Yeah, wait, it's working. Okay. Right. When I give the brightness, you check the option there. I will. Turn on, power on. Press power button. Okay. Now, is it clear? Yes. Okay, this is, I'm going to explain about the shift operator. Okay. That is left shift operator and right shift operator. Along with that, arithmetic right shift and arithmetic left shift operator. Anita. Okay, and here, this is the module. Here, whatever I declare, this is the module is a keyword. Silence. This is whatever I'm highlighted. This is as a module as a keyword, and followed by this is the operator. That is the module name. Okay, that is the module name. Here I give one The module name can you give as your wish. Okay, here I'm going to discuss about the operator, so shift operator here. Okay, and here this is the register is a keyword. Register is a keyword where I am going to overwrite again and again. For that, I am going to use the register. Okay, because I am overwrite in the sense, for example, for first clock cycle, A is equal to 5, I assigned. For the next clock cycle, I want to assign A is equal to 6. For that purpose, I am going to use register keyword here. Okay, the purpose of the register keyword is nothing but I'm going to overwrite on the variable. I'm going to overwrite on the variable by applying the clock signal. That is what I'm going to use the register as a keyword. And this is array declaration. 4:0. 4:0 is nothing but I'm going to assign 4 values. Okay, 4 bits. 4:0 is nothing but it is going to consider 4 plus 1, 5. Maximum it is going to take 4 plus 1, nothing but 5 values, 5 bits value I'm going to assign here. Okay, and followed by the register. Again, I'm going to declare that ABC. ABC is nothing but that is the variable I'm going to assign. I'm going to declare because as you know in the C language, after in the main program, we are going to declare the variables, integer, character, float. Is it or not? In the same way, this is similar as of your C language, but here the same. Instead of main, we are going to use module and module name here. That is what we are going to see the operators here. And the register, I'm going to again declare the register signed. I'm signed in the sense it is going to consider the A and B is a positive value or negative value. For that purpose, I'm going to use as a signed keyword. Unsigned, the difference between the unsigned and signed is nothing but, for example, okay, for example, unsigned is nothing but if I take 8 bit, 8 bit is nothing but the value from the 8 zeros to 8 zeros to 8 ones. Okay, but if I convert this equivalent binary into decimal, this is 0 to 255. Okay, 0 to 255 here. Nothing but we call this as an unsigned value because 0 to 255 is nothing but unsigned value here. But if I 255 by 2 is how much? It is nothing but 256. 255 plus 6, 0. 256 by 2 is nothing but 128 it comes. Nothing but in the signed value, I'm going to use first 0 to 127 as a positive value and -1 to -128 as a negative value. Nothing but I'm going to, in order to represent the value for the separate positive value as well as the negative value, I'm going to consider that as a signed value here. This is 0 to 127. If I take this is a positive value, I call this as a positive. And this is -1 to -128. This is negative value. Nothing but if I want to represent positive numbers and negative number, at that time I'm going to use as a signed keyword. The purpose of using signed keyword is nothing but I want to represent the positive value as well as negative value. That is what we are going to use as signed keyword here. Unsigned is nothing but just 0 to 255. Nothing but all values are positive value only. Okay, by default it is unsigned only. But if I want to represent the signed value at that time, I have to use the keyword called signed keyword here. Okay, signed is nothing but in order to represent positive as well as negative values here. And along with that, I'm going to declare B and C as a 2 variables here. 4:0 as a 5-bit values. That is nothing but we call that as a 4:0. Nothing but we call that as an array declaration. Okay. And initial begin. Initial begin is nothing but again, this is also keyword in the Verilog. Okay. This is also in the keyword in the Verilog. I'm going to, for example, I want to initiate some value to the variable. A is equal to 5, A is equal to 7. For that purpose, I'm going to use initial. Initial is nothing but I'm going to assigning the A value, some random value here. Okay, begin why we are going to use, because whenever I'm going to use multiple statement in the program. Okay, for example, if I use initial this is the keyword and followed by begin and end. If I have multiple statement or multiple instructions. Multiple instructions are multiple statements. If I have this begin and end. If I have only one instruction, we need to have only one initialization, enough. So that only one instruction it is going to consider. Okay, whenever I'm going to use begin and end, it is nothing but in this we have multiple instructions or multiple statement program. Okay, for that purpose we are going to use begin and end here. Okay, and here I told A and B is some I'm assigning some values. 5 tick is nothing but that is a declaration in the Verilog program because I declared A and B as a 5 bits. Okay, initial what register 4 is to 0, 4 plus 1, 0 is also considered as a 1 value in the computer. Okay, 5 tick of B indicates binary value. B indicates binary value followed by some random value I'm going to declare for both A and B in order to verify the shift operator. Okay, I need to verify the shift logical shift operator. For that purpose, I'm going to assign some A and B values in this. Okay. And here next is I want to perform the shift operation. Okay, shift operation. Here the display star displays nothing but in the C language you are going to use printf statement. No, the same thing we are going to use dollar display. Dollar displays nothing but in order to display the values on the console window. Printf we are going to use in the C language. The same thing we are going to use dollar display in order to whatever the this statement you are declared original value of a this value it is going to display on the console window here. Okay, and of a original value of a just I'm going to first I want to show what is the value of A and B. I need to verify what is the value of A and B after performing the shift operation. What is the next value before and after values? So for that one, I'm going to display the original value of A and B. This is modulus B. This is percentage symbol. We call that as a modulus or percentage symbol. B is nothing but I am going to use as a binary values here. I'm going to use binary value here. B is nothing but I'm going to use binary value and followed by which variable I'm going to declare A. That is what you have to specify A variable. If you want to specify B, you have to specify B. Whatever the variable you are going to declare, that variable name you have to specify in the dollar display statement. This is within the double quote. All these are all what statement. This is the quote. Within the double quote, this is the statement. What you need to display on the console window and followed by what variable you have to display. That the variable it contains some values. That value I had to assign by using modulus percentage B. Percentage B is nothing but what? It is going to display the value of the A or B. Because I'm declaring A and B as a binary value. That's why you are going to use percentage B here. Okay, and here this is left shift operation. C is equal to here what you are seeing here in this. B is equal to this is double less than nothing but we call that as a logical shift operation. Logical shift operation. What is the value of B here? Previously I have 10100. What is the value of B? I convert it to binary to decimal. What is the value of B? The decimal value 1, 2, 4, 8, 16. Nothing but 1. It is 20. The decimal value. Okay. So 1, 2 for it. This is the binary value because the human can understand decimals. That is why, but computer will understand only the binary values. Okay, I'm going to convert binary value into decimal value in order to analyze the problem statement here. Okay, and next, this is also just and double, sorry, and this is double left, this is double less than operator. This is double left operator. We call that as a left shift operator. We call that as a logical left shift operator. And if I specify triple left shift, this is we call that as a arithmetic left shift. The difference between logical and arithmetic is nothing but if I specify only double less than or double greater than is nothing but we call that as a logical operator, logical shift operator. We call that as a logical shift operator. Okay, and if I specify 3 times of logical shift, 3 times of less than or 3 times of the greater than symbol, we call this as a arithmetic operator. Arithmetic shift operator. We call this as a arithmetic shift operator. The difference between arithmetic and logical shift operator. This is okay. You have to understand what is the mean by logical shift and what is the arithmetic shift operator. How we are going to represent. But now we see the functionality. What is the difference between arithmetic shift and the logical shift operator here? Okay, and see here the A is nothing but what I'm going to perform. This is logical left. This is okay, and here I'm going to perform the logic. This is arithmetic left shift of B and A. Okay, I'm going to perform the logical shift. This is B double less than is nothing but logical shift operator, and this is triple less than is nothing but we call that as an arithmetic left shift operator here. Okay, and the same thing for A, B here. Okay, after executing, so what I do here, I have a run button. This is the EDF playground. We have a run. This is the program what I verify. This is the program I used in the Verilog program. Just you have to what? You have to, let me check. We have a run button. Okay. Are you seeing this run button? Okay, if I click on that, it will execute the program. Okay, if you go to the Google and type EDF playground, where it is gives the online compiler. Okay, you type the Verilog program. So in order to analyze the logical operators, okay, logical and arithmetic operators. See here, after that, here what I done, let me lift up this, scroll up. Okay, and here, original value of A is, okay, original value of A is what? Here, previously 10100. And original value of B is also 1011. Okay, and here I'm performing logical left shift of how many bit? Of how many bit I performed? This is what I performed. 2-bit logical left shift operation I perform. Nothing but it is shifting 101. Okay. Just add this one 10100. This is the value of B here. When I am going to perform the logical left shift operation is nothing but this bit it is going to shift to here and this bit it is going to shift here and this becomes 100 followed by this filled with zeros. Okay, this 0 is filled with 0. This is what we call that is logical left shift operator. Similarly, logical right shift operator is nothing but it is going to fill whatever the MSB value it is there, that is going to fill at the MSB value here. Yeah, sorry. This is logical right shift is also same thing. Whenever you are going to perform the logical left shift, if I want to, this is 10100. If I want to perform the shift operation, what it becomes 101 followed by divers. Nothing but to call this as a logical left shift and logical right shift operator. Okay, and arithmetic right shift and arithmetic left shift I will discuss. Okay, this is what we have to do. Just if you want to understand the operator operation, because theory sometimes I may be wrong. But if you evaluate the functions, if you try out the expressions, Verilog expressions using EDF playground, you will get much more clarity here because they will give 8 to 10 marks question. They will give the expressions you need to evaluate. Okay, try to practice more and more by using this tool because anyway you are not getting the ISC software. At least this is the online tool. You can try it and you can try the expression. You can try n number of examples that will be available in the online, in the internet, in the Google. Try out and check it out so that you get confidence on that whatever the expression you give, you can analyze it. Okay, this is for your reference. Just I'm suggesting you. Okay, is it clear? I'm in the next class. I'm going to discuss about the right shift and left shift operator, arithmetic right shift and arithmetic left shift operator.